In computer science, the double-double algorithm is used to convert binary numbers into binary-coded decimal notation. It is also known as the shift and add 3 algorithm and can be implemented using a small number of gates in computer hardware. But in Minecarft science, there is a thing called Redcoder. Firstly, every double-double piece receives 4 binary inputs. We take their sum and run through a well-known function that every double-double uses. Then, let's make a table of all possible inputs and outputs, where at some point, output starts to differ from input by 3. But I mentioned a Redcoder in the beginning, and if you'd have 10 outputs, that would be a pretty big circuit. But let me show you something. Let's label all the outputs that have 8 in them red. Outputs that have 4 yellow, let 2's be green and 1's blue. And you can see that the only difference between left and right side is 8. Get rid of 0 and narrow down a Redcoder to 4 or 5 pieces, where when a signal passes through this line, we output an 8 and shift the signal by subtracting 5. Now the Redcoder is way smaller, and we can build it in Minecarft now. First, we gotta build 4 inputs, 1 block between each. We'll use composers because they're one of pushable containers that hold a signal in them. But because composers can't hold a signal greater than 6, I use 2 composers, both outputting a signal strands of 4, one from the third input and the second one for an 8. We can do that because there is never an input that adds up to 12 or greater. Now we place comparators in front of composers and make a line where we subtract our inputs from a bigger signal. By that, we are creating a logic of summing our inputs. Next, we build a 4-piece Redcoder on top of composers, and we use glass here to avoid quasi-connectivity. And if you want to know what that is, you can search it up on Google. Now, around the most significant output, we build a circuit that checks if you need to output that bit, an 8. And because outputting an 8 also means that we gotta shift our signal by 5 up on the Redcoder, we need to send a signal up there. Now we gotta wire all 3 remaining double-double outputs with Redcoder outputs. Almost forgot to put this comparator back here. Now we can see our circuit working. We output a 2, that means we inputted a 2. We input a 3 and output a 3. 4 is in and out. 8 in, 8 is greater than 4, we add 3 to it. 5 is also greater than 4, we add 3 and output 8. I think I spent like 3 or 4 days designing this Dabble. Came across quasi connectivity, never heard of it before. Didn't find a smaller design on the internet. Mine is 7 wide, 7 long and 6 high, which I think makes it the smallest one. The link to download the world is in the description.